Hey guys, in this video we're going to be taking a look at a really neat way of organizing and representing data that allows us to really kind of easily see things like where the median may lie and how kind of the data is spread apart from the median. We're going to call this way of representing our data a box and whisker plot. So if you've ever seen a graph that looks like this before, it's referred to as a box and a whisker plot, just basically because this middle portion here is a box and then there's the outside portions here we're going to refer to the whiskers, okay? But without getting too much into this right now, let's just take a look at what it is and how we kind of organize our data in order to be able to make a box and whisker plot. So we say box and whisker plot organizes data into quartiles. And so the very first word we're going to visit here about is this word quartile. When we talk about quartiles, we mean fourths of something. And so really what we're going to be doing is placing our data in order, and we're going to be splitting it up into 4 equal sized pieces. And so we're going to be quartering our data, quartiles. Okay, so we say that readers can more easily visualize statistics such as median, max, min, and range when we organize it in this way, but it's also really convenient, I guess, when you want to compare different data sets, especially if they don't have the same amount of data. So we're going to take a look at this data set that I actually collected some data on here, and we're going to organize it and find out how we can make a box and whisker plot from what we see here first. So let's consider this data set. This is the resting heart rates of 10 randomly chosen adults, and they're all ages 20 to 40 at least. So we say that the 5-number summary is the first thing we're going to want to find here. And then from this 5-number summary, we're going to be able to create a box and whisker plot and kind of interpret the data and talk about how it'd be useful. So first things first, what is a 5-number summary? Well, I'm going to tell you first things first. When we talk about the 5-number summary in your box and whisker plot, I'm going to put boxes around these 5 portions of the graph here that you can see. But basically this 5-number summary is going to represent the 5 data values that we're going to be plotting on our box and whisker plot. But in terms of what they are, we say the 5-number summary provides a short summary of the distribution of observations for some variable being measured. And so in this case, we are looking at resting heart rates here. But for this resting heart rates here, you know, what are these things you could tell us, these 5 things? This would be at least the minimum and the maximum. And I always just say start with those. So those are kind of the outer numbers that we find in the 5-number summary. But the inner numbers here, we say the first quartile, the median, which you're going to notice that I say is the second quartile, and then the third quartile here. When we look up at the picture up here, I want to point these things out. The minimum and the maximum are always going to occur, at least on this picture, on the outsides of our graph. But in terms of quartiles here, I just want to start with median. And basically, because we're splitting this data set up into 4 equal sized pieces, our method is going to be that we're going to put it in order, split it in half, and then take each of these inner halves here and split those in half. But when you find these values here, you split it in half first. We're finding the median value here, and the thing that I'm going to tell you is really neat about this median value is that it is in the 50th percentile. We're going to come back and talk about this here. But basically, it represents the data value that if you were to say, I'm the median, half the data is below you, and also half the data is above you. But when we take these halves and split those in half, we get these kind of fourth marks here, or quartile marks. And so when we look at a box and whisker plot here, we say that after the minimum, we call this next data value the lower quartile, or mostly we call it quartile 1, because it represents the end of the first fourth of our data. When you look at the end of the second fourth of our data, 2/4 or a half of the way through the data, we usually just call that the median, but we could call that Q2 or the quartile 2. In other words, it's the end of the second fourth of the data. The end of the third fourth of the data, as you might guess by now, is called a Q3 or quartile 3. And then technically the maximum is Q4, but we just never call it that. We just call it the maximum. And so these 5 numbers I want to find with a data set like this, it's going to, I guess, require that we put it in order first. And so let's go ahead and start by doing that here. I noticed that this was 10 randomly chosen adults, and so I want to make sure that I put all 10 in order. Starting with the smallest, it looks like we have one in the 60s here, 64. And if I can't spot any less than 64, we're going to start with it. We're going to say 64 is our beginning datum, but we'll cross that off our list here. It looks like the next data value that still falls in the 60s here is 69. So 69, then we hop up to the 70s. Looks like we have a 70 here. I don't know if we have any other 70s. Looks like we have a 70 up here, so 2 70s. So 70, 70. We're going to go for 71 next. So that's half of our data set there. No other 71s. Looks like no 72, 73 though. So we're going to go 73, 73, 74, and 75. So we're going to put 74 and 75 on our list here. And then it looks like it goes into the 80s, and we end with 80 and 82. So now, when it comes to the 5-number summary, I'm just going to give you my best practices advice here. What I'm going to tell you is put it in order, and then just throw a box around the first and the last data values, because we're just going to label these as the min and the max values. And we can already put that down here for our 5-number summary. Those are always the easiest two to determine here, 64, and then we have 82. And in terms of all these data values here, I'm going to make this a little bit easier for us here, but units would be BPM here. And we would technically always want to label these, but we say 64 beats per minute and 82 beats per minute. And so when we talk about these inner data values, the very first one we're actually going to go for is the median. So when we find the median, if I have an even number of data points here, in this case I have 10 data values, I'm going to have to count in on each side, maybe 1, 2, 3, 4, and then maybe I count in 1, 2, 3, 4. In either instance, what you're going to find is that you actually land on 2 data values. So remember that when you're finding the median in this case, I'd say put a box around them, throw a line between them, and what I want you to do is average these 2 values. And so I am going to actually write the expression here that represents the average of these 2 values. But I will tell you that we get 72, it's got to be 72, right? 72. So 72, I'm going to throw on top and put a box around it. Now this is our Q2. In other words, it is our median. And so we're going to say our median data value is 72 beats per minute. Now in terms of finding Q1 and Q3, here's what we're going to do. We're going to take, and I'm going to switch colors here to like a green. We're going to be looking at our first half of data and our second half of data, okay? And we're going to be splitting those in half. So here's the rule. I hope you're listening. We're going to put parentheses around the first half of our data, and the rule is this. You start to the left of our minimum datum, and you go to the right of the data value that falls within the first half of data. Now when I say within, I mean that if 72 is your median, you always start 1 to the left of this, because this is kind of our first half of data value, data values here. The median doesn't get counted in that first half. And likewise with our second half, you could kind of look at it as, okay, well it's going to be these data values right here. But you always start 1 to the left and 1 to the right of the median to get your halves of data. But we're going to be splitting these in half. And as I count in now, I say 1, 2, 3, 4, 5 data values total. I should land on this middle 70 here when you do count in with your fingers. And so we're going to give this a name here. I'm going to call this Q1, not Q2. I was looking at Q2 there. Q1, and then counting in over here, looks like we land on this middle 75 when you count in from the 82 and the 73 here. And I'm going to call that Q3, quartile 3. And so we're going to go put these also down on our data set here, but we say 70, and then this would be our 75. So first things first, I want to talk about some things here. These 5 data values, as I mentioned earlier, are going to be the 5 data values that we represent on our box and whisker plot here. And so in terms of this graph that we're about to make, we're going to put it over a number line over here in our number line, and that's also going to require that we kind of construct a number line that would be appropriate for the data set that we're given here, that represents 64 through 82. But we're also going to interpret what this graph means, and so that's where I want to kind of stop and look at all of these definitions here and how they relate to the graph. But then we're going to go construct our graph from our data set that we've already got a 5-number summary of. So looking at a few things here, the max and the min, the largest and smallest data values, recall that these occur on the outsides of our data set here. And so what this does is actually, I'm going to start with this, it also gives us a good idea of the span of our data. Now the span of our data, we actually statistically give a name. So we're going to define this idea of what we call the range here. And the range, by definition, is the difference between the maximum and the minimum data values. So you can see our formula here is max minus the min. And I'm going to write that up here, max minus the min. But the idea is that this graph is going to be really good at easily showing us how far our data set spans. Is it consistent and really, brief, or is it really spread out because maybe we have big or small data values here? Next up is our median. Now remember, our median is the middle data value. Now you heard me use a word earlier. It says the end of the second quartile, but also the 50th percentile. So we're going to take a moment now to define what we mean by this word percentile, and start with the fact that we use a percentage to represent a percentile, but a percentile is not a percent of something, okay? Or I guess it is, but in terms of how you generally think about it here, what it is a percentage of, and let's go down and look at the definition here, is this. It is a measurement of position, first of all, when the data is listed in increasing order, but it gives the percentage of scores in the data set that fall below the given data value. So when I'm sitting here talking about the median being the 50th percentile, what I mean is when I put all this data in order, 50% of the data values lie to the left of this data value. And so what that would mean by definition of percentile is that it is in the 50th percentile. Now, talking about some other percentiles here, let's talk about our lower quartile, or quartile 1, because that's, these quartiles split our data set into fourths. This is the end of the first 25% of data. This also means that what quartile 1 represents is our 25th percentile. And that is to say that putting our data in order, 25% of the data falls below this. In other words, you could look at it as it's 25% of the way through your data set. And so as we're on this topic here, we're also going to write over here that Q3 also does represent the 75th percentile of our data here. It's bigger than 75% of the rest of our data. And so that leaves our minimum and our maximum. And I think it's worth writing here that this is considered to be the 0th percentile. If you're the minimum, you're bigger than none of the data. And then this would be the 100th percentile in the end here. But we mostly pay attention, what I'm going to tell you now is, to the middle 50% of our data. So when it comes to these graphs, in a moment when we construct our graph, the thing we're going to be paying all of our attention to really, mostly, is going to be really this. Where is the median? Right here. And what is the span of our middle 50% of data? And that's really what we care about most of the time. What's kind of in the middle? These outside whiskers kind of represent outer data, or in some cases outliers, which we're not going to go too much into, but this middle box is what we're after. And so we're going to make a little note here that this is the middle 50% of our data or stuff is from here to here. And because that is so important that we want to know the span of this middle 50% of data, I also want you to write this here. We're going to give this a name. We're going to refer to this as the interquartile range. Now when we talk about interquartile range, this is kind of like the range that you see up top where we found the difference between the max and the min. But in this case, we're only going to find the difference between the end of the middle 50% of data and the beginning of the middle 50% of the data. Or in other words, the end of Q3 and the beginning of Q2. And so this interquartile range, we have a definition for this, and we say that it's the range of the middle 50% of data, but it's really the span of the box. And when we talk about this, it's going to be Q3 minus Q1. So when we talk about 5-number summary, really this is going to tell us really how far the middle 50% of our data, or really the middle solid chunk of our data spans. So let's go talk about now how I'm going to construct this box and whisker plot, and these data values here. We're going to follow up with just range and IQR. So in terms of my data, I will say this, it goes from 64 to 82. Data like this, I would really be inclined to say don't zoom all the way in. That is to say, don't start at 64 and go to 82 by ones. We would do something like maybe start at 60 and go up to 90. And I would be more inclined to say if I'm going to go that far past 82, going up to 90, I'm going to go a little bit further before 64. So maybe I do something like this. I say like, how about 50 to 100? And so by doing this, what I can say is 50, 60, 70, 80, 90, 100, and then what that does is it gives me a really good span on my number line here. And I could even put smaller middle tick marks here to kind of represent the inner values, and I'd actually be inclined to write in these values here. Now in terms of labeling this graph, we're going to give it a title, but we're going to say resting heart rates. So we always want to title it, and then we're going to say in beats per minute, if I can get a proper P here. We could also write this down at the bottom below our axis. But essentially what I want us to do is to take these 5 numbers, and for every one of these numbers elevated above the line, we're going to put a dot. So that means 64, our minimum value here, we're going to put a little dot here where 64 would be. If this is 65, here's 64 in my best judgment. 70 is my next number, and I'm going to put these kind of all collinear with one another. 72 is my next data value, so closer to 70 than to 75 there. 75 right between 70 and 80, and then 82, which would be kind of, I feel like, clear over here. And in terms of making this graph, what we're going to do is these middle 3 data values, it's always the middle 3, we're going to put vertical lines through them and then kind of create this rectangular space around it. And then the whiskers are just going to be these lines that go to the outside here. Now in terms of our graph, sometimes you'll see graphs where people actually would label this, like if it's an Excel graph, it might give you the option to like put these values above it. When I'm writing it here by hand, I feel like it's kind of hard to fit all these in, but a lot of times you won't see this, but you might see your 5-number summary off on the side. So in terms of what I want to be able to determine about this set of data, the range here, we're going to start with this. I'm going to write the formulaic version of it before I write any calculations, but 82 minus 64, I believe we get 18, and I'm going to label this beats per minute. So that means, for these 10 people, from the highest to the lowest resting heart rate, this is about 18 beat per minute span. Now that's a lot, I feel like, given certain individuals. It's random. But you're going to see that what's the middle of our data do? That's going to be our IQR. And this is going to be where we're going to take Q3 minus Q1. And I'm also going to write this one out. We say 82 minus 70. And so I feel like this gives us a truer idea of what resting heart rates would be like, if you look at the middle chunk of people, there'd be about a 12 beat per minute span. And this was granted just for 10 people. So the next video we're going to take a look at how changing the number of people in your data set is going to make a difference. Cheers.